Number 1, find the following value of a such that that expression equals x to the a if x is positive. So we somehow need to simplify all of this down as x to some power. And I think the easiest way to do this is going to be make everything an exponent again. So let's take this numerator, the cube root of x squared. I can rewrite that as power over root. So I can rewrite that numerator as x to the 2/3, power over root. And then in the denominator, I'm going to have to use a power to a power property, so I'm going to multiply those and get x to the 4/3. When I divide, I subtract my exponents, so this gives me x to the 2/3 minus 4/3, which gives me x to the negative 2/3. So what is the value of a? A equals negative 2/3. That's the magic number for which that expression is equivalent to x to the a. If I wanted to rewrite this, and I'm done with the question now, I could rewrite this expression, x to the negative 2/3. Well, the negative flips it. The negative puts it in the denominator as 1 over the cube root of x squared. But we were done at this point right here because they just wanted to know the value of a. Justify why the square root of the square root of x is the fourth root of x. Well, I'm going to start with this side of the equation and make it look like that side. So the square root of the square root of x. Well, the square root of something is the 1/2 power. The square root of something is the 1/2 power. Well, again, I have another square root. So I can write that as x to the 1/2, and that's the 1/2 power. And when I have a power to a power to a power means multiply the exponent, which gives me x to the 1/4. And we know x to the 1/4, this is saying take the fourth root. Take the fourth root of x. So the square root of the square root of a number is really just the same as the fourth root of that number by going through these steps here. By applying these properties of exponents, we can start with the square root of the square root of x and get the fourth root of x. Number 3, write the expression as x to a, where a is a rational number. So I somehow want to collapse all of this nonsense down to x to some power. Working my way in, I see I have a big cube root. Well, a cube root is a 1/3 power. Cube root is a 1/3 power. That square root is a 1/2 power times x over x to the negative 2. Inside in the numerator there, 1/2 plus 1 gives me x to the 3/2 over x to the negative 2 to the 1/3. Well, what is 3/2 minus 2? Because when I divide, I subtract the exponents. Minus negative 2. 3/2 plus 2. 3/2 plus 2 is what? Please don't reach for your calculator at this point. You know how to work with fractions. It's 7/2, because 2 is 4 over 2. 3 plus 4 is 7. 7/2, but I'm raising that to the 1/3 power. A power to a power means multiply, so I get x to the 1 times 7 is 7, 2 times 3 is 6. So what's the value of a? Oh, no, it wanted me to write it as in that form. So x to the 7/6. So knowing how to use our properties of exponents, and especially with these rational exponents, making the connection between square roots and cube roots and writing them in terms of exponents is extremely important. Number 4, rewrite each of the following expressions using a single radical. So the first one is x to the negative 3/2. That negative puts me in the denominator and makes the exponent positive. And remember, it's power over root. I have the square root of x to the 3rd. I can put a 2 there, but whenever we're talking about square roots, we normally don't include the index on the radical and just leave it out. So power over root gives me the square root of x cubed. I have a power to a power, so I can multiply them. I have x to the 12/5. Well, how can I rewrite x to the 12/5? The fifth root of x to the 12th. 3x to the 2 over p. Well, power over root. I'm raising the whole 3x here. So 3x is going inside power over the pth root, because p is the type of root I'm taking, and I'm going to need that squared. So knowing power over root is beyond essential. Use properties of exponents and radicals to rewrite this nonsense as x to the a. I see a big fourth root, so I have a fourth root. A fourth root becomes a 1/4. I actually like the x to the 8/3 in the numerator. That denominator, power over root, can become x to the negative 2/3. Okay, I'm dividing. When I divide, I subtract the exponents. 8/3 minus negative 2/3 is going to be 8 to the 10/3 raised to the 1/4 power. A power to a power means multiply, so it's x to the 10 times 1 is 10 over 12. This is x to the 10/12. Did I write it as x to the k? I did. If they said write it as a radical, I would have to write it as the 12th root of x to the 10th, or maybe the 12th root of x raised to the 10th power. But this is our final answer because they said write it in that form. We did. Number 6, explain why did we define x to the 1 over n as the nth root of x. This is very important to understand why we defined x to the 1 over n as the nth root. We know explain means write sentences, so we know that x to the 1 over n raised to the n power, when I have a power to a power, has to give me x to the 1, which is x. So that tells me x to the 1 over n has to give me x. But we know the inverse relationship between exponents and powers. We know the nth root of x raised to the n gives us x. So therefore, these two must be equal. These two quantities must be equal. You should understand why we defined it this way instead of just memorizing power over root. You need to memorize it, but you should also know where it comes from. That we don't want to break previous rules of exponents. We don't want to break the power to a power rule. So we're going to have to define 1 over n so that the power to a power rule still holds true.